right, I'm gonna make this key as a video as well. So for this table here, we know that a triangle has a base of 4 and a height of 3, is enlarged and reduced according to the table below. Complete the table. Remember, the area of a triangle is base times height divided by 2. Okay, so and I put a little note here. If k, or the scale factor, is unknown, you have to find that first if you're trying to fill in your table. And the one that has a scale factor of 1 and is all filled out, that is your original triangle. So in this case, we're making copies of that original. So we always, like if we're looking at that second row, you almost want to ignore everything else, right? And just work with those two. And then when you're done filling in that one, you want to basically ignore everything else and just compare the original to that. I call it new sub 2, and then new sub 3 and sub 4 and so forth. So that's how you do a table like this. All right, so in this case, we don't know what the scale factor is. Okay, so I have the height of both triangles, and they're both in centimeters, so it's going to be actually fairly easy. But remember, in this case, I'm going to use that k is equal to new over original. Okay, that's what I'm going to revert to. That's what I'm going to do. These are the terms I'm going to use instead of diagram actual. I rather use new and original because copies are being made of a certain shape. Okay, there's no diagram or blueprint or anything like that mentioned. All right, so that means that for this, I would have to take 1.5, right? The new divided by 3. Okay, and you know what? Stating it as a decimal is fine. So it'd be, right, you already guessed it, that's 0.5. I'm going to use my other calculator here. So 1/2 or 0.5, either way is fine. Okay, and then we have, now that we have the scale factor, finding everything else is actually pretty straightforward. You can set up a proportion somewhere outside, or just going by this equation. If you put a 1 here, okay, and we're, or if k happens to be a fraction, you don't need to put a 1 underneath. But basically, if this is your unknown, you'd have to multiply by k, right? Original times k. So new is k times original. Okay, so that's kind of like, I'm going to keep that in mind for everything I do. And so now I want the length of the new triangle. So then I take my k, which is 0.5, and I multiply that by 4 centimeters. So that would give me 2 centimeters, the length of the base for that new one I've created. Okay. With area, it's a little different. It's still going to be k times original, like that same pattern, but it's going to be k squared, right? So k squared, because it's area of the new times, right, times the area of the original. And so if you type that in, 0.5 x2, like if I use this calculator, there's an x2 button right here. Okay, so you go square that. You can go right, and then times 6, or you can go do it in one shot. So that's 1.5 is the area and centimeters squared. So let's say you didn't get this part. You're like, what? K squared? Okay, I will put this on the side here. That area of new is k squared times original, times area of original. Okay, so this is always considered length, right? Width, and so forth. But this is one-dimensional. When you're dealing with areas, you got to make sure that your scale factor is squared, because the scale factor has affected 2 dimensions of, right, you have affected both dimensions, the base and the height of that triangle. So 1.5. But let's say you didn't know that. How else could you have done that? Well, remember, the area of a triangle is base times height, right, which is 3 divided by 2. You could have found it in this case a different way, but I want you to do it this way because not always will you have all the dimensions needed to find the new area. And so here's area of new triangle divided by area of original. So here I just want you to see how the areas have been affected. So you go 1.5 divided by 6, right? So 1.5 divided by 6, which is 0.25, which is k squared. Okay, and no units there, but that's how you know that their areas have not been affected by k, which is 0.5. They have been affected by k squared, right? Like this is the same as that. So there we go. Next, now we're dealing with original and this one, okay? So it's a little messy, but don't worry about this one. And we are given k already. You know the scale factor, so no need to find it. So we're just going to go k times the original. So that's 12 centimeters. So first of all, I want to say that k is bigger than 1. So we know that this is an enlargement. Like from the original to this shape, it's going to be an enlargement. So everything should be bigger than the original. Okay, so let's keep going. My scale factor is 3 times 3. You have to be careful not to use this one. It's that one. And that's 9 centimeters. You can watch this faster too, right? And then the scale factor here is 3 squared times the area of the original. So that'd be 9 times 6, which is 54 centimeters squared. Okay, and then you take the area of the new divided by that, and that is 9, which is also 3 squared, right? Like k squared. Every single one of these is going to be k squared. Okay, just to remember that. Next, we have this, which is 0.25, right? And we know k is less than 1, so it's a reduction. So from the original to this new shape, we know that all these will be smaller. And so we go 0.25. We take this k, multiply it by the original, and it's a quarter, so it's 1 centimeter. And 0.25 of 3, that's 0.75 centimeters. The area will be, let's go back to k, 0.25 squared times the area of the original, which is 6. So we go 0.25, square it, times 6. That's 0.375 centimeters squared. Nothing wrong with doing that. It's a finite decimal. You're not going to lose marks if you do that. And then here we take 0.375, which is the area of the new, divided by the area of the original. Right? So I'm just going to go ahead and divide that answer. You get 0.0625. And you're like, where did I get this from? That's supposed to be k squared. So k is 0.25. Let's square it. And sure enough, it's 0.25 squared, right? It's k squared. Ultimately, when you divide the areas of those two shapes. New 4 here. It's a little, I had it a little crooked there, sorry. So now this is more challenging. You don't know k, but you have both of the areas, right? So to get this, okay, I'm going to do the work here. I have to square root, right, the area of the new, and remember it's centimeters squared divided by centimeters squared. And we want that, right, because these are going to cancel out because we want our scale factor. So it's essentially, this one ends up being nice and easy. 600 divided by 6 is 100. Square root, you have to press second and then x2, right? And then you type in 100. So we knew that it was 10, right? The scale factor is 10. So then now we're like, we get 10 times 4, remember always to the original, 10 times 4 is 40 centimeters. Once you have the scale factor, it's the same as before. This is 30 centimeters. We already know this, but if you didn't, it's base times height divided by 2. You should get 600, and then we go 600 divided by 6, that's 100, which is 10 squared. It's our scale factor squared. It's always scale factor squared. I'm going to highlight that. Scale factor squared, right? Scale factor squared. Scale factor squared. Scale factor squared. Right? It's always like that. And so that's how you fill out that chart. Let's do some word problems now. Just going to do this a little bit. Okay, so here we have a parallelogram. Really, the shapes that come up in this unit don't really matter all that much. I want you to use right, the fact that, right, k is the dimension of the new over dimension of the original. So this is if we're talking length, like length and length, diameter, diameter, so forth. But if you're talking areas, it's area of the new divided by area of original. But notice that now it's k squared. So here, if you wanted to find the scale factor and you have both lengths, all you have to do is divide them, you're done. In order to get k here, you need to take the square root of that answer, of the whole thing. Okay, so if you want the scale factor, you need to get the areas and then square root them. Okay, volume is going to be cube root, right? So keep that in mind. All right, let's keep going. A parallelogram has an area of 42 centimeters squared. So now the area of that parallelogram and the volume is this. So maybe I should already bring that up right away. That k cubed is the volume of the new over volume of original. Meaning that to get the scale factor given those volumes, you're going to have to take the cube root of volume new over volume of original. The way I suggest you do it is divide this, then take the cube root of that number, and you'll see in the examples how I do that. Okay. So we have the area, the volume, and this is going to be enlarged by a scale factor of 5. There it is. They give you the scale factor, so you're not going to have to find it. Okay. Determine the area and the volume of the new parallelogram. Okay. So again, the wording I'm going to choose to use when it's this type of scenario is new and original. Okay. So for question 2 here, what do I have? I have, so maybe what we should do is almost set it up like this. This is the original, right? And the scale factor is 1, right? And the area is 42 centimeters squared. The volume is 95 cubic centimeters. Okay. And so now you want the new. So it's almost like you're doing a table. And this new one has a scale factor of 5. We don't know this, we don't know that. Okay. So to get the area of the new, we are going back to this equation here, right? Where to get the new is area of the original times k squared, right? Like if you had a 1 here, it'd be this times that divided by 1, which is irrelevant. If k is a fraction, you don't need to divide it by 1, right? I turn that into a decimal, or just do cross multiplying, dividing with that fraction. Okay, so here we go. Area of nu is k squared times the area of the original, which is 42 centimeters squared. So we're going to end up with centimeters squared, right? So that is 25 times 42. And so now we can calculate that, sorry. That's 1,050 centimeters squared. That's the area of the nu. So I'm going to make sure I write this down here again, right? So that's what I'm after. So if we had a table, we'd fill that in right under here. And now we're going to do the volume, right? So this is my area calculation. Okay, the volume of the nu is the scale factor cubed times the area of the volume, sorry, of the original, which is 95. 5 times 5 times 5, or 5 cubed, is 125 times 95. And you just go 125 times 95, 11875. Okay, and this is centimeters cubed, because remember this was centimeters cubed here, so that follows. And so volume of the nu is this. Okay, and we expected that because k is bigger than 1 enlargement, right? Okay, that's 2. Let's go over to question number 3. Let's see, I'm mixing it up here. A photo measures 4 inches by 6 inches, so a photo is 4 by 6 inches. Using software programs, it is enlarged by 150%. So that's actually your scale factor. And it makes sense that it's enlarged because this would be 1.5, right, as a number, and with no percent, to fit it into a frame purchased previously. Calculate the dimensions of the frame. Okay. How could you show how you could calculate the area of the frame using 2 different methods? So you're like, oh, photo, this is going to be diagram and actual. No, I'm going to use this as my original, and the enlarged version is the new photo. Okay, that's what I'm going to use here. You can use diagram and original, but I would use it this way. So the dimensions of the frame, so basically the original, if you think of k, is 1, right? And the length and width, I guess I'm just going to go 4 inches, 6 inches. The actual length doesn't matter, right? Which one you make length, which one width, but I'm just going to go length times width, basically. And this is the area of this original will be 4 times 6, which is 24. And there's a reason why I'm doing this, right? So basically you're filling in your chart. And so then the new one that you're making is enlarged by 150%, which is 1.5. It's a one-dimensional here, so it's 1.5 times 4, which is 6 inches. This is 1.5 times 6, which is 9 inches. And so the area of the nu would be just 6 times 9, which is 54 squared inches. So that's one way of doing it. Area of nu, second method. Area is just length times width, right? I hope you understand that. Area of nu could have also been found by going 1.5 squared times the area of the original, right? So then we go 1.5 squared times 24, and that's 54, which we expected, squared inches. Okay, so squared inches, get it right. So two different, this is method 1. And this is method 2. Okay. All right. Question 4. Where are we time-wise? Okay. It's getting longer. A rectangular display with dimensions 2 meters by 3 meters is located in the lobby of City Hall to show citizens the layout of the new People's Park. The display was created using a scale ratio of 1/120. Answer the following questions without calculating the new dimensions. So here I don't want you to actually find the length and the width and stuff. I want you to use the properties we learned, right? Where you just use k squared to find the new areas, you use k cubed to find the new volumes, and so forth. So anyways, the dimensions are 2 by 3. And it's a display, so you can use diagram here, right? The display was created, like the display of the actual park, right? The display was created using a scale ratio or just a scale of 1/120. Answer the following questions without the new dimensions. So right off the bat, I'm going to take that scale ratio and I'm going to say that 1/120, it doesn't even have units, so it's perfect. We can just say, let's turn that into a scale factor. And it's perfect that it's a fraction because it works a little different when I solve. And so it says, the Parks Department estimates that the city spends about 75 cents per square meter to maintain parks from the spring through fall. Determine the cost to maintain the People's Park. Okay, so what I want you to do here is I want you to basically find the area of the diagram or the model, right? Would be 2 meters by 3 meters. And that is 6 meters squared. So that's the area of the diagram. And always remember, k squared in this case is area of new, but in this case we can use diagram over area of actual, right? So this is what I'm going to use because from this, I know the scale factor, right? But I'm just going to use that to set up, and it's a fraction in this case, that's what the scale factor is, right? So I'm going to use that scale factor. Whenever you have it, plug it in. Oh, don't forget to square it because we're comparing areas. Area of diagram is 6 square meters, whereas area of actual is going to be found. Okay, so here I want you to do the following. We're going to square both numbers. 1 squared is 1. 120 squared is that, 14,400. So I go 1 over 14,400. It just prevents you from rounding too soon. I'm going to make this x, right? So it's basically cross multiply and divide. Okay. So in this case, I'm not using the formula or whatever. I will show you that it also works. Like the shortcut, I should say. So 6 times that divided by 1. Obviously, you would show your work here, right? 6 times 14,400 divided by 1. And that's 86,400 square meters. Okay, we're not done yet. We need to find the cost. Okay, but this would be the actual area, right? Of park. Yes, I could have done the shortcut, which is area. I'm just going to leave it like that because in this case, that shortcut works best. And what am I talking about? These shortcuts work best with tables like that when you just aren't trying to find the new dimensions, okay? So here we go. Pencil. We need to figure out the cost. So a couple of ways we can do that. I would say this. You're given a rate, right? 0.75 cents for 1 square meter. So you're asking how much would it cost, right? Knowing that the area to be maintained is this big, how much would it cost, right? We should call that Y because we already used X, right? So you cross multiply and divide. 86,400 square meters times 75 cents divided by 1 square meter. Square meters cancel out, so you're left with dollars. So just multiply that by 0.75, and it's $64,800. Right? That is what the question is actually asking. So I took my scale factor. I knew that we were working with areas, so I had to make sure my scale factor is squared. So this is what I used to set it up. And yes, I had to figure out the area of the diagram because those are the only dimensions I had. I want you to work with this, not find the new dimensions and then multiply them, because it's not always going to be the case. Okay. All right, 5. Determine the scale factor that relates each pair of similar shapes. Okay, so let's go ahead. Question 5. Trapezoid with an area of 5 centimeters becomes a trapezoid with an area of 11. So the original area of original is 5 centimeters squared. Area of new, this is where I'm going to use new, is 11.25 centimeters squared. So we're relating areas. Okay, so you know that therefore k squared, right, because areas are affected, right, by a factor of k squared. I'm going to go area of new over area of original. So you start with this, right? K squared would be 11.25 centimeters squared over 5 centimeters squared, which is perfect. They cancel out. Now I need to take the square root of both sides, right? Technically, if you take the square root of both sides, the square cancels out. It's okay if you just do that without the square root. I will get it. So it's 11.25 divided by 5. And then this is actually not too bad, so I'm going to show it. Sometimes when you take the root, you have to make sure you round. In this case, so I'm going to go square root of what? I'm going to do second, and then answer is at the bottom here. As soon as you press second, you're using the yellow part, and so I'm going to do answer, right? Second answer, and that's 1.5. That's my scale factor in this case. 5a this was, right? 5a. I'm going to try to do 5b right here. 5b, a sphere, there's volumes, right? So k cubed is volume of, new, sorry, don't mix this up, volume of original. So k cubed is, again, the original is 24, the new is 3. Okay, cancels out. And so k, how about this? You just k, there's another way of doing it, right? If you want k, you need to take the cube root of both sides. So k is cube root of 3 over 24. So I go 3 divided by 24. And then I go math. Cube root is the fourth option. You can, in this case, just type it in, or you can go second and that negative at the bottom there, so it's 0.5. And we knew that it was a reduction because it got smaller. This should have been an enlargement because we ended up with a bigger shape, right? So there it is. Question 6, we're almost done. Toy tractor has a length of 19.1, width of that, height of that. The scale ratio is that, so I'm already, for 6, I'm saying K is 1 over 16, right? So 1 to 16 turns into this, okay? So it's a fraction. I like to keep it that way. Determine the dimensions of the real tractor. So here, I will say that diagram is probably better because it's a toy and you have all those dimensions. So that's my diagram, right? A model, whatever is the diagram. So actual is going to be there, okay? So this is how I'm going to do it. The length, right? Sorry, it's a little messy here. The length is, I'm going to do the work here. 1 over 16 is the scale factor, would be diagram 19.1 centimeters over, let's call this L, just L like that. But this is actual, okay? Cross, multiply, and divide. So length is really 19.1 centimeters times 16 divided by 1. Not that we need to do the divided by 1, but there we go, 305.6 centimeters. And we do the width. Again, I'm starting with my scale factor, and these are all linear, one-dimensional measurements, so no squaring of anything, okay? So this is just 9.5 times 16 divided by 1. It's 152 centimeters. And the height, again, I'm using the same scale factor. It's 12.7 centimeters over height, cross multiply and divide. You can probably fast forward. It's 203.2 centimeters. Okay, so these are actual dimensions. So I'll just say tractor, like the toy tractor is going to be my diagram. Okay, just to keep that in mind. Question 7. A carving located at a museum in Windsor is 6.5 feet tall and 2.5 feet wide. Museum gift shop wants to sell replicas that are 26 inches tall. What scale factor must be used to produce such a model? Notice that we're focusing on scale factors a lot more than scales, okay? Because scale factors are unitless and are easier to work with. So what's happening here? You want to make replicas, right? And so the actual, right, carving. So I'm going to use original, and you want to make replicas, so we're going to make a new of the original. Okay. So I'm going to put an arrow there to that. And so for A, how would I need to find a scale factor, and we're having the height and the width, right, or the how tall and how wide. So it's one dimensional, so you don't need to go squared or cubed or anything like that, but you need to relate them. So in this case, you have the how tall it is, right, and the height of the new is also given, so you have both heights, so to speak. Okay, so that's what we're going to use. So the width is kind of, for now, irrelevant. So I'm going to go 6.5 feet is the original. and this is 26 inches. So obviously we have a problem. Let's convert 6.5 feet. Everything comes back. Everything comes back. Everything we've learned, right? Foot goes here, so it's 6.5 times 12. That's 78 inches, because I have to have both the same, right? So 26 inches over 78 inches, cancel them out, right? You can divide them by 2 for sure to get it a little smaller. That'll be 39. And what do you know, right? 13 goes in there once, goes in there 3 times. And just to double check, right, you go 26 divided by 78. It sure is 0.33. So not that I would have been okay if you left it here, or you turn that into a decimal, or you go 33.33%, right? You go by what's on your screen, right? You go and times that by 100, and then round it to 2 decimals when you write that down. All right. So we found the scale factor. In fact, we gave it in 3 forms. So B, what would the width be of the model? And you have a choice here. In this case, they are not specifying the width, like what unit it should be in. I'm going to use, how about we use the 26 over 78, right? And we know, remember that the top is always our new and the bottom is the original. Remember that. So we have the width of the original, which is 2.5 feet, right? 2.5 feet. And so we haven't used X yet. So the width of the new will be found by doing this. So how about we just go ahead and cross multiply and divide. 2.5 feet times 26 divided by 78. This is like that. 2.5 times 26 divided by 78. That is 0.8333. This keeps going, and we are in feet, right? I'm pretty sure that you will want that in inches as well. So 1 foot has 12 inches. Cancel, cancel. So just take what's on your screen, multiply that by 12, and that's 10 inches. There we go. That is it for this page. And that's all for now. All right. Thank you. Hope this helped.